Good morning. Myself Arun Kumar K, and I am working as Assistant Professor in Aeronautical Department, MLR Institute of Technology, Hyderabad. See, I am dealing with Thermodynamics subject for this semester. So, Thermodynamics common for mechanical as well as aeronautical. So, we will start the session with Introduction to Thermodynamics. So, in today's lecture, we are going to discuss about the definition of thermodynamics, and I am going to explain the thermodynamic various process with practical applications. We will enter into the slide. So, the first one is nothing but with respect to the various units, what are the course outcomes actually we are having according to the syllabus, that we will see one by one. Right. See, in the first unit actually we are going to discuss about apply first law of thermodynamics to real-time applications. Right. See here, the first law of thermodynamics we are going to apply with respect to the real-time applications. In that, we are going to discuss about steady as well as unsteady processes. See, everyone knows about what is meant by first law of thermodynamics. In unit number 1, actually we are going to discuss about the definition with respect to understand level. Right. And after that, we are going to apply this first law of thermodynamics in the real-time processes. See, we know that first law of thermodynamics is nothing but law of conservation of energy. One form of energy is converted into another form. So, with respect to that, actually, we are going to apply in the real-time applications. That is what actually we are going to discuss in the first unit. So, that's why the course outcome 1 is nothing but we are going to apply the first law of thermodynamics. See, we are having certain limitations with respect to the first law of thermodynamics that we need to overcome. That leads to the second law of thermodynamics. Or we can say in other parameter, we are going to evaluate the performance parameter of energy transfers. That is what actually we are going to discuss in the unit number 2. We are having limitations with respect to the first law of thermodynamics, which means, see, in simple terms, I can able to say that a certain quantity of energy in one form is converted into same quantity of other form of energy. That is what the first law of thermodynamics states. It won't say with respect to any performances. See, if I calculate the efficiency or performance parameter with respect to the first law of thermodynamics without any losses, we can say the particular component is having some percentage efficiency. But in actual cases, that won't happen. So, those limitations we need to overcome with respect to the performance evaluation. Right. So, for that we need to enter into second law of thermodynamics. So, that is what the evaluation of performance parameter of energy transfer. So, that is what actually we are going to discuss in unit number 2. We can say overcoming the limitations, or we are going to enter into the next law of thermodynamics. Right. See, after knowing all these basic properties of thermodynamics, then actually we are going to apply. I am going to evaluate, see, the property of gases during phase changes. See, in the first 2 units actually we are going to learn about only the basic concept of thermodynamics and various basic laws. Right. But in unit number 3, we are going to evaluate the properties. What is that actually? Thermodynamic properties we are going to evaluate. Once I know the performance parameter, then I can easily able to enter into how to evaluate the thermodynamic properties. Right. That too with respect to the ideal gases, first of all we are going to apply. Right. Ideal gases, that too with respect to during phase changes. Everyone knows that we are having, in general, we are having 3 phases. One is solid phase and another one liquid, and last one vapor phase we are having. Right. With respect to these 3 phases, how my property of particular gases get changes. Right. We can say with respect to the temperature, or we can say with respect to the pressure during any heat addition process, how these properties are changing with respect to the phase changes. That is what actually we are going to discuss in the unit number 3. Alright. See, the course outcome 4 is nothing but we are going to compare the process parameters in mixture of gases. Right. See, with respect to the individual gases we have applied in the first step, After that, we are going to apply with respect to the mixture of gases, right? This mixture of gases actually, we are going to evaluate the properties and we can say the parameters, right? So, comparing the process parameters in mixture of gases, right? So, for that actually I suppose to use general laws, like actually we are having Avogadro law, right? And we are having Charles law, right? So, those laws actually we are going to apply with respect to the mixture of gases, right? Dalton's pressure law we are having. So, these are all actually applicable with respect to unit number 4. Then, the final motto of this subject is nothing but actually we are going to distinguish the process of various power cycles, right? See, for the particular thermodynamic devices, say for example, we can go with automobile engines, right? So, for that actually we are having for the comparison purpose always we supposed to take the ideal processes, right? So, with respect to the ideal processes, we need to compare how much actually we got it, like the efficiency parameter, or we can say other performance parameters also, right? So, that is what actually finally we are going to do with respect to this subject. Got it? So, these are the overview of we can say introduction about thermodynamics and what are the chapters we are having and what we are going to discuss. We will move to the next slide. See, first we will start with the definition of thermodynamics. First of all, you need to know what is meant by thermodynamics and what it deals with. Right. See, in this actually, let me read out this definition. Right. The branch of science that deals with energy level and the transfer of energy between systems and between different states of matter. Right. So, in this actually, I suppose to mark two parameters, two things. One is nothing but energy levels, right? See, with that energy levels, I can able to say that how much energy is available with respect to the particular thermodynamic devices. So, if I know the energy level with respect to one form to another form, how it get transferred. So, these two parameters actually mandatory for the thermodynamics. One is nothing but actually, see, the branch of science that deals with energy levels. So, how much energy level actually we are having, that is what actually available energy, right? For example, with respect to the any heat engine or any automobile engines actually, we know the calorific value of the fuel. For that particular calorific value, I know how much heat energy is generated. Now, I am having the energy level. For example, I am having 100 kilojoule, right? 100 kilojoule of energy I am having. That 100 kilojoule of energy transferred to any useful work done or not, and how much it transferred. That is what actually we call it as transfer of energy levels. Got it? See, with respect to this 100 kilojoule, I can't able to convert this 100 kilojoule into useful mechanical work done or useful energy, right? So, in this 100 kilojoule, I can able to convert only 70 kilojoule. Remaining 30 kilojoule, we supposed to consider that as the losses, right? See, which means energy level I am having 100 kilojoule and this 100 kilojoule is converted into other form of energies. That is what transfer of energy. In that also, see, listen here, we are having, we can categorize with respect to between systems, right, and between different states of matter, right. So, between any two systems I can able to consider with respect to system A and with respect to system B, right. Assume the system A is nothing but actually energy produced system or energy generated system. With respect to system A, I suppose to transfer energy to the system B, right. So, this is what actually transfer of energy between systems. In that systems also, we may have different states of matter. What is that matter actually? With respect to A, I might have oxygen as the working substance, for example, I am telling, right. And with respect to B actually, I might have nitrogen as the working substance. Got it? So, this is what actually we are having different states of matter, right. The working substance with respect to the systems get differs. That is what actually we are going to deal with this thermodynamics subject, right? Yes, this is the simple definition for thermodynamics. So in that actually particularly two parameters we need to consider. One is nothing but energy level or capacity, and another one is nothing but transfer of energy, right? Yes, see, with respect to the practical applications, right? With respect to the practical application, let me tell you about how this energy transfer is taking place. In the previous slide, we discussed about, I said 100 kilojoule energy is generated, and with that 100 kilojoule, I have converted that into 70 kilojoule useful work done, right? In practical cases, how to sense that, right? How to understand that? For that, actually, I can take the steam power plant, right? Everyone knows that for electricity production, right? Current generation, we required a steam power plant, right? So the power plant is nothing but actually we call it as the engine that is working with respect to the steam, and it can able to steam power plant. In that steam is nothing but actually we call it as a working substance, right? With the steam, I can able to produce a useful power, right, through the generator. That is what actually we call it as a steam power plant. To produce the electricity, right, we require this steam power plant. So with this steam power plant, you can able to see right here. See, inside that actually I am using this working substance. What is that actually? We are generating the high pressurized steam and high temperature steam, right? So for that actually I supposed to do some work. What is that work actually? I supposed to supply the heat energy to the boiler, right? See, we are having the boiler as the first component over here. Inside the boiler, I am having a liquid, as in this is actually water I am having, right? From the water, I can able to convert that into steam, right? See, through this fuel and air, I can able to generate the heat energy with the help of this furnace, and that heat energy is supplied to the boiler. That increases the working substance temperature so that the high pressurized steam is generated, right? So we know that the calorific value of fuel, with that calorific value, I can predict how much available energy is there in the system, right? That is actually sensed with respect to the heat energy, right? That heat energy is converted into transfer to the boiler, right? That heat energy actually used to convert this working substance with respect to liquid phase to steam phase. So here liquid actually we are having, I can mention with respect to L, and this is steam, or we can say vapor, right? We can go with the vapor. Why? Because S denotes actually always with respect to solid. So we can go with vapor, V. So now this high pressurized vapor actually strikes the turbine. So the turbine rotates. So with that we can able to get the mechanical work done, right? So from this turbine it is connected to the generator through the shaft, right? So by this actually I can able to generate the electricity. So see here, actually here the energy transfer takes place, right? And we are having the particular energy level. This energy level I can able to sense with the fuel, calorific value of fuel. As in that this is actually 100 kilojoule I got as the energy. This 100 kilojoule is converted to the working substance, and this is transferred to the turbine, right? So how much I can able to get through this generator? I can able to calculate the how much energy output actually we got, right? See, for the cyclic process actually we require the condenser. With the condenser actually I can able to cool down the working substance so that I can able to remove the heat energy from the working substance. Once the heat energy is removed, what happen actually? It can able to convert from vapor to, right, liquid. But this is liquid is actually we are having low pressure liquid. We are having low pressure liquid. We know that the boiler is actually at high pressure. So from low pressure to high pressure, the flow won't happen. For that we require the pump, right, to feed the water. So this is what actually the steam power plant works, right? So this is the basic application actually we are having. With that actually we come to know what about the energy level and what about the energy transfer takes place, how it is transferring, that we can able to know, right? See, another one example is nothing but actually we call it as gas turbine engines, right? generally we are using in the jet engines in aircraft industries, right? In aircraft industries, we are using the jet engines. For that, actually, what we are doing, we are getting the hot gases as the working substance, right? How we are getting actually in the combustor. Combustor is nothing but actually we call it as a boiler over here. See, through this combustor, the fuel is sprayed inside that, and we know that with the help of the compressor, I can able to pass the bleed air, right? So, we have difference between normal air and bleed air, compressed air, right? So, with that I can able to start the combustion process. Once the combustion process starts, what happen actually, I can able to get the heat energy, right? Plenty of heat energy. That plenty of heat energy is passed through the turbine, that is hot gases, through the nozzle. It strikes the blade so that I can able to get the rotary motions. So, once I get the rotary motions, what happen actually, this is connected to the, instead of load, you can connect it to the generator. So, I can able to get the power output, right? So, this is what actually how energy is, energy level we are having and how much energy level we are transferring to the neighboring system. Got it, right? See, this is what actually we are having for the compressor, we are having air as a working substance, but here the combustion, we are having the hot gases as the working substance, right? The combination of air and fuel, right? In the turbine also we are having the hot gases. So, this is what actually the matters also get changes, that is how the working substance changes. This is what actually we are going to deal with the thermodynamics subject, right? Okay, now see, in order to enter into this thermodynamics subject, actually we required two kind of viewpoint. One is nothing but macroscopic viewpoint and another one is nothing but microscopic viewpoint. See, in this macroscopic, actually I supposed to consider, we'll discuss about the microscopic first. The microscopic, I supposed to consider a composed of pack of molecules as a matter, right? Matter in the sense, inside the working substance, actually the matter actually which I am considering is nothing but a pack of molecules, right? I supposed to consider number of molecules, right? Number of molecules I supposed to consider. But in case of macroscopic approaches, see, listen here, a certain quantity of matter is considered, right? We are not taking, right, with respect to the molecular level, only with respect to the certain matter. What is that actually? I am having mass m1. So, that is what actually I supposed to consider for the macroscopic approaches, right? So, see, listen here, with respect to the microscopic, actually with respect to the individual gas molecules, we are getting the different properties. Is that right? See, if I am evaluating the pressure with respect to particular this molecule, as in this is the molecule 1 we are having exactly at the center, right? It possesses actually less pressure when compared with the other molecules which is near to the wall. Why? Because we know that with respect to the wall, actually I am having molecular collisions. So, that has actually more pressure. Average of this thing is nothing but actually we call it as, see, with the pressure gauge I can able to mention, right? With respect to the indicator, it can show 2 bar. That is what actually we call it as macroscopic, right? So, for thermodynamic analysis, actually we require macroscopic approaches, right? So, then why we are having these microscopic approaches? This is actually required for the chemical engineerings, right? Only we are going to discuss only with respect to the physical engineering over here, that is thermodynamics, right? So, that is why we are having this microscopic and macroscopic approaches we are having, right? See, you can able to see here, it is only concerned with the effect of the action of many molecules. So, average of this microscopic property is nothing but we call it as a macroscopic value, right? With respect to individual molecules, actually we are having the different properties, but overall as the average I am having the overall property, that is nothing but we call it as macroscopic approaches, right? This macroscopic approach properties actually we are going to consider for the thermodynamic analysis. So, this is about today's lecture, right? In tomorrow's lecture, we will discuss about what are the various types of systems we are having, right? And how we are going to classify the systems. Thank you very much.